7 years ago, I went to a conference in New York City on science and the arts. Around that time, I happened to see a video simulation of black holes in space merging and the gravitational waves, etc. And I thought, wow, that looks like dance. There is a phenomena that happens called event horizon. I wanted to recreate that on the stage, so I created a short piece called Event Horizon. And I was so amazed at the audience's reaction because people really were like, wow, that's cool, I've never seen that, or whatever. And it kind of got me thinking, oh, maybe we could expand this a little bit.
Thomas Warfield knocked on my door and told me, what do you think about using dance to communicate astrophysics and science to the general public and to hard of hearing and deaf underrepresented communities? I really got very excited about this idea, and soon after we collaborated together, formed a team, and decided to write a proposal to the National Science Foundation, and this is how the entire project started.
RIT is extremely unique in that we have this one college where we have about at any given time about 1,500 deaf and hard of hearing students on campus. You walk through the halls, you walk in different buildings, outside, you'll see hearing students signing with deaf students and deaf students communicating with hearing students. And as part of that, we're kind of building programs where deaf and hard of hearing students can become involved in astrophysics research and can pursue their interests in astrophysics if they have them. Astrodance was a collaboration between CCRG scientists and faculty of the National Technical Institute of Deaf in the theater department. And what we did is we developed a dance program, an interpretive dance program, where we used real simulations and real general relativistic simulations, astrophysics simulations. We created an interpretive dance program with deaf and hard of hearing undergraduate students, and we created a production of this. The idea being that deaf and hard of hearing students really pick up on visual cues. So if they can see something, they can understand it. So we took this unique blend of art and science, we merged them together in such a way that that if you were a deaf or hard of hearing audience member, you could understand.
So the Astrodance project was focused on how to communicate research to public audiences, and so we're talking about people who might not normally go to a science center, might not still be in school and have classes in science, but might be going outside to theatre or dance or that kind of thing. So that's why we developed this sort of performance, that the scientific concepts could be communicated through the performance to the members of the public.
Welcome to Astrodance, where dance and science come together to explain ideas about astrophysics. Astrophysics is the study of where objects in the universe come from and the way they interact with each other. We're going to use dance, stage props, and projection to enhance our learning and understanding about the universe. We'll see real images from telescopes as well as simulated films created by scientists.
We had ideas about, black holes and black holes merging, supernovas and the stars collide, gravitational waves, those kinds of things.
For Astrodance, I had in mind to use very simple to understand visuals, colorful visuals, but not something which is tiny, really only big things. The process is normally I talk to scientists what they have in mind, what they think about it. And then I literally lean back, sit in my chair for a couple hours and think about it. How should it look like? And if I have it in my brain, I draw it on a piece of paper. And if the drawing is convincing enough, I write the code which creates an image of it.
And so as we got deeper into trying to understand these concepts, I realized that the concepts were actually more abstract than tangible. So I think the audience really needed to go on a journey that was more abstract.
What do you think is the difference between the people who create Astrodance and me who creates this visualization? They're artists, right? An interesting part was you have two different languages. Manuela and I speak the same language, the language of mathematics and science. Thomas speaks the language of art. And in order to get these two languages together, one of us had to learn the other ones. And at the end of the day, both people understood what the other one meant. I can take this movie and show it to pretty much everybody who is interested without any words, and he or she can tell me what's happening.
A century ago, Albert Einstein proposed a theory predicting the distortions in the fabric of space-time called gravitational waves. Gravitational waves are ripples in space-time caused by the rapid motion of huge objects. Just like a boat sailing through the ocean produces waves in the water, all moving masses in the universe produce gravitational waves in the fabric of space-time. Violent events, such as the collision of two black holes, supernova, explosions, and even the Big Bang itself, produce waves strong enough to be detectable on Earth.
Astronomical observations today indicate that almost every active galaxy has a black hole in their center. These black holes are extremely massive, and for example, if you think about our own galaxy, the Milky Way, it does have a black hole that is 4 million times more massive than our Sun. And what we see is that galaxies have collided during the history of the universe, therefore leading to the collisions of the supermassive black holes at their centers.
So using black hole perturbation theory, we can get an estimation of what the gravity should look like around them. And then when you step out another step, you can get the post-Newtonian theory, which describes the motion of the black holes in a Newtonian gravity sense, plus gravitational corrections due to Einstein's theory of general relativity. And then when you are very, very far away, you can get to the gravitational wave zone, which is the far zone, and that describes the outgoing radiation from the binary. And so I work on making these approximations and stitching them together into a full picture of what this black hole in spiral should look like from a gravity point of view.
The physics community may witness a new discovery, the discovery of gravitational waves. In fact, the Advanced LIGO detector is getting ready to observe such gravitational waves in just a few years from now. And when that will happen, then a new window into the universe will be open.
Let's watch how the dancers will move across the stage representing the expansion of the universe through galaxies, past our sun, to Earth, and arrive at a measuring tool called LIGO.
So several members of the CCRG, myself included, and most notably also Professor John Whalen, are members of the LIGO Scientific Collaboration, or LSC, all collaborating to analyze the information from this interferometric gravitational wave detector, which is measuring the transverse stretching and squeezing of a set of arms as a gravitational wave passes by.
It's been constructed to detect gravitational waves from the collisions of black holes and the collisions of neutron stars.
And this laser can measure distances really accurately. So when you measure these two distances, if there's a change in the distances relative to one another, this LIGO detector will pick it up, and that's a sign for gravitational waves. And that would be the first direct detection window.
The reason scientists have LIGO to detect and measure the waves is because gravity governs a large part of the behavior of the universe. These measurements would answer many scientific questions. Let's watch one of the dancers show us waves using different parts of the body. Notice how the fluctuations and the rippling effect is similar to the idea of frequencies in gravitational waves.
Hey, let's all try doing waves. Come on, stand up. You can do it. Come on, stand up.
Everyone learns science in a different way, and so it's important to have a variety of different ways for people to be able to learn science. Some people learn well by sitting in a lecture about the science, but then a lot more people learn in a lot of other ways by trying things out, using their hands, moving around, or by watching a performance kind of thing and understanding how that connects to the science that was going on.
And so in a way, I think it really had to do with both dance and science really equally, even though science had the content, dance was the vehicle, but you could see science in a different way and you could see dance in a different way.